Condensation is a phase change from a gas to a liquid. When condensation occurs, gas particles lose thermal energy and begin to slow down and move closer together, often forming water droplets on solid surfaces. This would be like what you would see in the bathroom after you take a hot shower, when the water condenses on the mirror. So in this case, going from a gas to a liquid, if it's water, for example, the water would be losing thermal energy. Sublimation is a phase change from a solid straight to a gas, which looks pretty cool at Halloween in a bubbling cauldron. Here in the picture you'll see what is called dry ice. Really, this is the solid form of carbon dioxide. Since carbon dioxide is a gas at room temperature, when you put dry ice out at room temperature, it immediately sublimates from the solid form into the gas form. So it goes straight from being in the solid form where the molecules are kind of locked into maybe a crystal pattern, and immediately goes out into the gas form. So there has to be an increase in thermal energy, and in the case of dry ice, just the temperature of the room is enough to cause carbon dioxide as a solid to move to a gas state. Here's one that's not listed in your book. It's called deposition, or it could also be crystallization. This is kind of the opposite of sublimation, where a substance goes from the gas straight back to a solid. This might happen on a very cold day where maybe water vapor freezes in the air, or on a very cold surface where the water vapor in the air freezes fast to maybe a metal pipe or a window or something that's other surface that's very cold. So again, this is going straight from a gas to a solid, skipping over the liquid phase, and this requires a loss of thermal energy. Thermal energy has to be released or removed from the substance. The molecules slow down, they lose kinetic energy, they move closer and form a solid. So again, if we look at all the possible phase changes, we can look at it in terms of going from solid to liquid to gas. All of these require an increase in thermal energy, and as we move from a solid to a liquid to a gas, the molecules begin to move more and spread out more. Liquids can spread out to fill a container, but they maintain their volume, where gases do not have a definite volume or definite shape and will spread out to fill whatever area they are in. Sublimation also requires an increase in thermal energy as well. If we go the other direction, from a gas to a liquid to a solid, this requires a loss of thermal energy. The particles will begin to slow down, and the more thermal energy lost, the closer they'll become, closer together they'll become, and you'll move back through the liquid to the solid state. Or you can have gas to a solid directly, and that's called deposition. Now let's talk for a moment about what happens during these phase changes. We talk about melting and boiling points. So melting is the point where a solid will change into a liquid, or we might also call this point freezing, where a liquid will go back into a solid. And then we have the boiling point, where a liquid will become a gas. So these are the temperatures at which the phase changes happen. And something interesting goes on during these phase changes. So I keep stressing to you the fact that the substance has to gain thermal energy in order to change its state from the solid to the liquid to the gas. But during the actual phase change, the actual melting, the actual evaporation, those melting and boiling points, the temperature stays the same. And if the substance is gaining energy, the energy is going to breaking up the molecules, separating them, spreading them apart. Or if it's the other way, we have to lose a certain amount of energy, and during that point when they're either condensing or freezing, the temperature will stay the same. So here's a graph that represents what happens during a phase change. So if you have a liquid and you begin to lower the temperature, at the point where it starts to freeze, let's say this is water, it's here at 0 degrees Celsius, the water will stay 0 degrees Celsius until it's a solid, until it's frozen. And then the temperature might continue to drop from there, but at that point it would already be a solid. Or if we go this way, again talking about water, moving from a liquid to a gas, we begin to increase the temperature, but at water's boiling point, 100 degrees Celsius, the temperature will stay the same until the water has evaporated, and then once it's all a gas, the temperature could begin to rise again. So, and then over here again we see, liquid water, water ice, water vapor. These are, the points at which they would be in those states. But during the phase change, the temperature stays the same. So here's just one more graphic kind of to summarize everything. It's using water again. So we talked about, moving from a liquid to a solid requires a loss of thermal energy. We call that freezing. Or moving back from the solid to the liquid, we'd have to gain thermal energy. You have to have energy being absorbed. And we call this the melting point. If we're going from liquid water to water vapor, again, we're gaining thermal energy. And then as we come back from a vapor, we're losing thermal energy back during condensation. So it's really important to think about how energy is either being released or absorbed during these phase changes and what's going on with the molecules, what's going on at the molecular level. Are they slowing down their motion as they're, condensing or freezing, or is their motion increasing as they're melting or evaporating? So on the last couple slides here, I have some questions for review. Remember to answer these questions as part of the summary section on your Cornell notes. So question number 1, how does the thermal energy of a substance change from a liquid going to a gas? And remember, you can pause to write down your response. And then how does the thermal energy in a substance change as that substance goes from a liquid to a solid? Number 3, how at the boiling point of water in Danville, which is about 500 feet above sea level, compared to the boiling point of water if you were in Denver, Colorado, which is called the Mile High City, so that would be over 5,000 feet above sea level. On this phase change graph, what's happening to the temperature at the point indicated by the arrow? So here along this line, what is happening to temperature? And number 5, what state of matter is skipped during sublimation? Okay, don't forget to fill in your Cornell notes and answer the questions as part of your summary. And this ends our lesson on phase changes.